So let us, am I audible?
Yes, sir.
So let us start this lecture. So last time we were proving this snake lemma. So let me draw the diagram. So this is the diagram actually. So 0 to kernel f dash to kernel f to kernel f double dash to 0 u bar v bar, and then 0 to m dash to m double dash to 0. This is u and v. These are the inclusion maps. So the vertical arrows are actually the inclusion maps. Now 0 to then 0 to n dash to n to n to n double dash to 0. So these mappings, this is a mapping, this mapping is f dash, this is f, and this is f double dash. 0 to co-kernel f dash to co-kernel f to co-kernel f double dash to 0. So these are the natural maps, these arrows. This mapping I call u dash v dash. These are the natural onto maps, these vertical arrows here. Okay. Then u dash bar v dash bar, where u dash bar and v dash bar, they are compositions of composition of u dash with this natural map. Okay, where u dash bar is defined in this fashion: u dash bar of any n dash plus image of f dash equals u dash n dash plus image of f, and this similarly this v dash bar of n plus image of f equals v dash of n double dash plus image of f double dash. Here you have n dash belonging to n dash, n double dash belonging to n double dash belonging to n double dash, n belonging to n. Okay. Now we have to see that this sequence is exact. Our aim is to show that the sequence, this sequence starting from here. Okay. So यहाँ से यहाँ भी आपके पास inclusion map है. So from here to here, this is actually the tracing of the mapping D. This sequence is exact. Okay. So we have to show that we have to show that the traced sequence. This is the map D, by if you remember. This is nothing but the map D. ये जो यहाँ से यहाँ है, this is your map D. So we have to show that the traced sequence and I we defined this mapping D in the previous class, and we have shown that it is a well-defined homomorphism. Okay, we trace the trace sequence is exact, where D is defined in this fashion, where D of D of D of any x double dash equals y dash plus image of f dash, where what is x double dash? X double dash belong to kernel of f double dash. So x double dash is equal to v of x belonging to m, x belonging to m, and x belonging to m. So v dash of f of x equals f double dash of v of x, which is f double dash of x double dash, which is equal to 0. So this actually implies that this f of x belongs to kernel of v dash, which is equal to image of u dash. So this means this f of x equals u dash y dash belonging to m dash n dash, sorry. तो इस तरह हमने इसको डिफाइन किया था. मतलब ये जो हमारे पास y डैश आ रहा है उसकी ये प्रॉपर्टी है. y डैश जो है वो u डैश y डैश के लिए u डैश y डैश जो है वो f ऑफ x है, और f ऑफ x आपका कर्नल ऑफ v डैश में है, और x की ये प्रॉपर्टी है कि x दिस v ऑफ x इज x डबल डैश. ये सारी चीजें हमने देखी थी. दिस इज एक्चुअली द कंस्ट्रक्शन ऑफ द मैपिंग D. So we will be using this one. Now, to show that this sequence is exact, we need to check the exactness at this point, this point, this point, this point, and this point, respectively. Now, इस point पे ये clear है because since u is injective, so u bar is also injective. Okay. So exactness at kernel f dash. Now, since u is injective, now u bar is the restriction of u on kernel f dash. U bar is the restriction of u at kernel f dash. This means u bar is injective. So therefore the sequence is exact at kernel f dash. So which shows the exactness at kernel f, which shows exactness at kernel f dash. Now exactness at kernel f. Next, exactness at kernel f. Now second, exactness at kernel f. Means what? We have to show that image of u bar is same as kernel of v bar. Okay. So to show that image of u bar is same as kernel of v bar. So let x belong to kernel of v bar. So this means x also belongs to kernel of v because v bar is the restriction of v. And kernel of v is same as image of u by exactness. So by exactness of this row. Okay. So so this means x is same as ux dash for some x dash belonging to m dash. And so if you take a u dash of fx dash, now this square is commutative, so u dash f dash is u dash composition f dash is same as f composition u. So this is actually f of u of x dash. Okay. So which is actually equal to f of x. Now x is f of x is 0 because x belongs to kernel of f. I know. Because x belong to kernel of f. क्योंकि x आपने कर्नल ऑफ v बार में लिया है. कर्नल ऑफ v बार का डोमेन क्या है आपका? कर्नल ऑफ f. कर्नल ऑफ v बार इज ए सबसेट ऑफ कर्नल ऑफ f, है ना? Kernel of v bar is a subset of kernel of f. So f of x is 0. So actually this says that this so 0 equal to f of 0. Okay, f of u dash of 0. 0 equal to u dash of 0. So u dash f x dash is u dash 0. Now u dash is also injective. by the exactness. So this means fx dash equals f dash fx dash equals 0. Sorry, f dash x dash. इसको f dash लिखना है. Okay, so f dash x dash equal to 0. This is because u dash is injective. Okay, so this means your x dash belongs to kernel of f dash. Kernel of f dash. X dash is in kernel of f dash. तो x dash आपको domain of u bar में मिल गया. Okay, so this means x, which is ux dash and ux dash, जब आपको x kernel of f dash में मिल गया तो kernel of f dash पे u और u bar same है, because u bar is the restriction of u on kernel of f dash. So on kernel of f dash, u and u bar are same. So you can write it as u bar of x dash. So this means this x belongs to image of u bar. So this means x belongs to image of u bar. So this means what? Kernel of v bar is a subset of image of u bar. Now conversely, if if x belongs to image of u bar, then x equals to u bar of x dash, which is the same as u of x dash, where x is in kernel of f dash, where x is in kernel of f dash, because the u bar का domain जो है वो kernel of f dash. Okay, so f of x equals what? F of u of x dash. F of u of x dash. But this diagram commutes. So f composition u here. Here f composition u is same as u dash composition f dash. So this is u dash f dash of x dash, which is equal to, now f dash x dash is f dash x dash is 0. इसको मैं x dash लिख रहा हूँ, because x dash हाँ कर्नल ऑफ f dash में हमने लिया, तो f dash x dash is 0 हो जाएगा. So this is u dash of 0. now u dash भी इंजेक्टिव है, ठीक है, या यहाँ से आप कह सकते हैं x belongs to kernel of f. This means x belongs to kernel of f. लेकिन x ऑलरेडी इमेज ऑफ u बार, तो इमेज ऑफ u के बराबर भी है on its domain. So therefore x belongs to kernel of f intersection image of u. Now, image of u is same as kernel of v, which is equal to kernel of f intersection kernel of v. Now kernel of f intersection kernel of v is nothing but kernel of v bar, है ना, क्योंकि v bar आपका जो है वो kernel of f से मैप है. So kernel of f intersection kernel of v is kernel of v bar. So x आपने लिया image of u bar में, x चला गया kernel of v bar में. So this means image of u bar is contained in kernel of v bar. So this establishes exactness at f, which shows the exactness at f, at kernel f, which shows exactness at kernel of f. Okay. So next we have to show the exactness at kernel of f double dash. So third, exactness at kernel f double dash. So what we have to show? You have to show that image of v bar is same as kernel of d. Okay. Now suppose x double dash belonging to kernel of f double dash such that x double dash belongs to kernel of d. So this means what? D of x double dash is 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 zero of this d. D कहाँ से कहाँ है? Zero of co-kernel f dash. Zero of co-kernel f dash. Zero of co-kernel f dash is actually image of f dash. Image of f dash, which is actually zero of co-kernel f dash. But by definition of d, by definition of the mapping d, d bar of x double dash जो है वो आपका है y dash plus image of f dash, where by construction of d, if you remember, x double dash आपका है v of x in m, and f of x is actually u dash y dash in n dash. This is by definition of. So यहाँ से आपके आपके पास, now these two equations are same, so therefore this implies actually that y dash belongs to image of f dash, image of f dash. So this means your y dash is say f dash x dash, where x dash is in m dash. So this means your f of x is actually u dash y dash. तो y dash की ये वैल्यू है, so u dash f dash x dash. Now by commutativity of the square, because this, so this square is commutative, so u dash f dash is fu. So you can just write it as f of u of x dash. So f of x is f of u of x dash. So this means what? This means f of x minus u x dash is 0. Or you can say that x minus ux dash belongs to kernel of f. ओके, तो ये एलिमेंट आपको कर्नल ऑफ एफ में मिल गया, x माइनस यू एक्स डैश एक एलिमेंट मिल गया जो कि डोमेन ऑफ वी बार में आपको मिला है ना, डोमेन ऑफ वी बार है ना आपका कर्नल ऑफ एफ। तो अब मैं इसी को दिखाऊंगा कि ये एक्चुअली एक्स डबल डैश की इमेज है, ठीक है ना। कर्न, सो यू हैव दिस, x dash माइनस u of x आपका चला गया, it is in kernel of f, and kernel of f is actually your domain of v bar. So I can apply v bar on this element. So v bar of x minus ux dash. But v bar is the restriction of v, so it is v of x minus ux dash. So this is equal to v of x minus v composition u of x dash. लेकिन आपका v composition u 0 है. So this is equal to v of x because image of, because ये sequence exact है. So image of u is same as kernel of v by exactness. So v of x आपका क्या है, x डबल डैश है, ठीक है. So x डबल डैश आपने लिया था kernel of x double dash you chosen in what, kernel of d में. Now it lies in image of v bar. So this means x double dash belongs to image of v bar, sorry v bar. So kernel of d is a subset of image of v bar. Okay. Now conversely, if x double dash belongs to image of v bar, then x double dash equals v bar of x equals v of x for some x in kernel of f. Okay, ठीक है. And no, x in kernel of f है. So this means f of x equal to what? F of x equal to 0, and this implies f of x equal to 0. Now 0 is also same as u dash y dash, क्योंकि अगर आप d की डेफिनेशन देखेंगे तो आपके पास ये आपका x डबल डैश जो है, d ऑफ x डबल डैश जो है आपके पास y डैश प्लस इमेज ऑफ f डैश है, ठीक है. और आपका जो v ऑफ x, ये f ऑफ x है, f ऑफ x इज u dash y dash, and this x double dash is also v of x by definition of d. So f of x is 0, which is u dash y dash by definition of d. Okay, so this means now u dash आपका इंजेक्टिव भी है, u dash is also injective. So this means y dash equal to 0. Okay, so this means y dash equal to 0 as u dash is इंजेक्टिव. अगर y dash 0 होगा तो आपका d of x डबल डैश क्या हो जाएगा? So this means dx double dash is image is equal to image of f dash, which is actually 0 of co-kernel f dash. Okay, so x, this means what? This means x double dash belongs to kernel of d. So this means your image of v bar is a subset of kernel of d. So this establishes the exactness at this point, kernel of f dash. Okay. Now exactness at co-kernel f dash. Okay. So exactness at co-kernel f dash. Co-kernel f dash means you have to actually show that image of D is same as kernel u dash bar. Image of D is same as kernel u dash bar. Okay. So first we will show that image of D is a subset of kernel of u dash bar. So let x double dash belongs to kernel of f double dash. Then by actually I'm writing the definition of D again and again. Then x double dash equals v of x is in M, and f of x equals u dash, y dash is in N, and d of x double dash is y dash plus image of f dash. Okay. तो ये एलिमेंट आपका y डैश प्लस इमेज ऑफ f डैश एक्चुअली कहाँ पे है? This element. So any element in the image of D actually looks like in this fashion. Now if I apply u dash bar on this element, now u dash bar of this d of x double dash, अगर मैं ये लूंगा, so it would be u dash bar of this y dash plus image of f dash. Now if you remember the definition of D and this definition of u dash bar, it is nothing but u dash y dash plus image of f dash plus image of f dash. Yeah, no def. If you remember, we written it in the beginning. U dash of this u dash y dash plus image of f. Okay. U dash y dash plus image of f. Okay. And now u dash y dash भी image of f का ही member है. If you see it, u dash y dash है ना, ये f यहाँ से यहाँ आ रहा है, ये n में जा रहा है, u dash y dash बेसिकली n में है. ठीक है. So u dash y dash plus this image of f. ठीक है। नहीं, और यू डैश एफ, अब इसकी हम वैल्यू सब्स्टिट्यूट करेंगे। यू डैश एफ, यू डैश वाई डैश की वैल्यू बेसिकली आपकी एफ ऑफ एक्स है, तो इसकी मैं वैल्यू यहाँ लगाऊंगा। सो दिस इज एक्चुअली एफ ऑफ एक्स प्लस इमेज ऑफ एफ। ना एफ ऑफ एक्स प्लस इमेज ऑफ एफ, तो इमेज ऑफ एफ के बराबर आ जाएगा, है ना, क्योंकि एफ ऑफ एक्स बिलोंग करता है इमेज ऑफ एफ में। ना इमेज ऑफ एफ क्या है? इमेज ऑफ एफ इज नथिंग बट जीरो ऑफ को कर्नल ऑफ एफ, जीरो ऑफ को कर्नल ऑफ एफ। ओके, so this means what? This means kernel of, now u bar composition, u dash bar of composition d equal to 0. So this means you can say that image of this d is a subset of kernel of u dash bar. So one way around you have the inclusion. Image of d is a subset of kernel of u dash bar. Now conversely, if y dash plus f dash m dash belongs to kernel of u dash bar, because any typical element of the domain of u dash bar is of this type, kernel of u dash bar, then u dash bar of this y dash plus, आप इसको image of f dash भी लिख सकते हैं, so no problem, image f dash equals f of m, which is image of f, which is actually 0 of co-kernel of f. Okay, but by definition of this mapping u dash bar, it implies that u dash y dash plus image of f is same as image of f, or this you can say that u dash y dash belongs to image of f. Okay, so this means u dash y dash, so this means u dash y dash equals f of x for some x in m. Now put x double dash equals v of x. अब ये v सब्जेक्टिव है, तो इसकी मैं प्री इमेज ले सकता हूँ, v of x equal to x double dash. Then f double dash of v of x equals, अब it is same as f dash of, sorry, it is same as v dash of f of x. Okay, so it is same as, now it is same as what? F of x की वैल्यू है u dash